The true benefit that you get from using quantum comes not just from having individual isolated computer sensors or communication systems, but it really comes when you start to connect multiple of these systems. When you have multiple computers connected, multiple sensors connected, and not just multiple, but the fact that they're at distance from each other. And so in the field of quantum networking, this is really what we're interested in. It is how you connect remote quantum benefits such that you can truly get all of these benefits. If you remember just a little bit ago, I said that you can get about 10 kilometers before you lose half your signal. But if you wanted to, for example, have a quantum computer or sensors connected between here and New York, that's about 7,000 kilometers. So there's absolutely no way that you could do that. So you also need some format to be able to send things over long distances. And in classical networks, it's very easy. You stick an amplifier in there. Unfortunately, you do not have that option when you're dealing with quantum states. There's something called the no cloning theorem that basically prevents you from doing that. We've actually, in addition to being able to use optical fibers, we've actually shown that you can use satellites to do entanglement over very, very long distances. This was a work done in China where they created an entangled state between two nodes kilometers apart actually through a satellite. We're actually starting to build these kind of test beds and move out of the lab and into the real world to test these things out. So I show here on the left, this is an example of a quantum network that was built in the Netherlands between Delft University and The Hague. On the right, this is an example of one that's being built in Boston, connecting Harvard, MIT, and the MIT Lincoln Lab. There's also networks in Chicago, in DC, in China. And so we're able to kind of really start testing these in real world settings. But there's still, I think, a couple challenges that need to be addressed, namely the scalability of these things. To implement a really large-scale network, you need thousands and thousands of devices. So a lot of the fabrication, we need to figure out how to be able to do a lot of this stuff more efficiently. And unfortunately, all these technologies really, really do suffer from their efficiency and the rates you can do things at.